Hi everyone, in this video tutorial I'm going to be going over common name substituents. Okay, these substituents are really important to know and you'll be hearing a lot about them throughout your organic career. So these substituents, remember, are groups branching off the longest continuous chain, and some of them, these guys down here, actually have common names that differ from their IUPAC substituent names. But these common names are acceptable to use in IUPAC nomenclature, and for the most part, you should be in the clear to use them in an IUPAC name as opposed to their substituent IUPAC name, which is just a little bit more complex. But these are pretty common substituents, and you should absolutely know them by their common name. Now, before we get into this, I want to just preface this by saying that it's easiest to exemplify these common substituents as being branched off of a cyclohexane ring, which is a six-membered hydrocarbon ring, and we're going to consider that to be the parent hydrocarbon. So that's why it's pictured in red. These are the parent hydrocarbons, these six-membered rings, and in black we have that common substituent. Another thing that I want to throw out here real quick is that we have this idea of something called the position of free valence. The position of free valence is the carbon of that substituent that is connected to the parent hydrocarbon. In other words, you could kind of visually slice and dice that bond there, and the carbons that I've indicated with our kind of red shading are going to be the carbons pertaining to the position of free valence, that connection point of the carbon of the substituent to the parent hydrocarbon. So you might see an isopropyl group, for instance, represented like that, or an isobutyl group represented like that, where this is going to be the attachment point to the parent hydrocarbon. Okay, and it's great to use these position of free valencies as a reference point when learning these substituents. So become familiar with this and really challenge yourself visually to get this down. So let's first talk about the isopropyl substituent. It's interesting here, iso is essentially going to represent this idea of a chain terminating in a carbon bonded to two methyl groups. So this is generically iso. And we have isobutyl and we have isopropyl. Now, if you just looked at this as being a substituent, that has three carbons, right? So that is isopropyl pictured here in the skeletal drawing. You have a carbon that is bonded to the parent hydrocarbon and it has two methyl groups. That is an isopropyl group. Its substituent IUPAC name is propan-2-il, but you can use isopropyl. It is an acceptable common name in the IUPAC system. We also have isobutyl. So again, this is considered iso because the chain terminates in a CH bonded to two methyl groups. But there's a total now of 4 carbons in that whole substituent. So we say it is an isobutyl substituent. And notice how it's this CH2 that is connecting to the parent hydrocarbon, okay? As opposed to in the isopropyl, the direct connection point was the CH of the iso component, okay? So that's isobutyl. Remember, we talked earlier about a straight chain butyl group. A 4-carbon chain might even be called an N-butyl group. N would represent that it is a straight chain alkyl group. N-butyl is a straight chain, or you might even just say it's a butyl substituent. Okay. Now, we also have sec and tert-butyl. Sec essentially means that the carbon at the position of free valence is a secondary carbon. It is bonded to 2 additional carbons, as opposed to tert, which signifies that that carbon at the position of free valence is tertiary. It is bonded to 3 additional carbons, again, besides that carbon of the parent hydrocarbon. Okay, so again, sec is saying that that carbon is secondary, 2 additional carbon attachments besides its attachment to the parent hydrocarbon, and tert is signifying that that carbon has 3 additional carbon attachments besides its attachment to the parent hydrocarbon. All right, so sec-butyl is saying that carbon is secondary, and we have a 4-carbon chain, but it is that secondary carbon that is attached to the parent hydrocarbon. We have a sec-butyl group, which is different, and you can see that just visually, right, from the isobutyl group or from a straight chain butyl substituent. And the tert-butyl group, again, is visually different, right? And we have this designation of it's a tertiary carbon that is connected to that parent hydrocarbon. We have a tert-butyl group, a total of 1, 2, 3, 4 carbons, a tert-butyl substituent. Now, we also call this a T-butyl group, or you might even see S-butyl as being the abbreviation here for a sec-butyl group. Tert-butyl groups will be really, really important. We'll talk about them quite a lot later in organic. Be familiar with the tert-butyl group as well as its condensed structure. Here would be its condensed structure. You have 3 methyl groups bonded to a carbon, which is then bonded to something else. And just real quick to recap the condensed structure for the isopropyl group before we move on. Here you would have CH3 to CH, and that's how it would be connected. The condensed abbreviation for the isobutyl group would be CH2, CH, CH3, 2. Okay. Now, we also have this funky group called a neopentyl group. This is really goofy, okay? So, not a lot of professors cover this, but it is important to know for some professors. Absolutely, it's kind of a cool group, but one that is covered less. Often, it is a neopentyl group. It almost kind of looks like a tert-butyl group, but there's one defining difference here. The attachment point at that position of free valence is a CH2, as opposed to it directly being, in the tert-butyl group case, that tertiary carbon. So here we could represent this in a condensed structure as CH2C, CH3, 3, where this carbon here is that one that is bonded to the 3 methyl groups. Now again, you can use these common name substituents in IUPAC nomenclature. They are actually easier to use and shorter in terms of constructing the name than their substituent systematic IUPAC names. So I'm going to clean this up for you real quick, and I want you to pause the video and take a minute or two to really digest this and compare and contrast them. All right, I want you to be able to differentiate them visually and articulate to yourself, the subtleties and how you have to visually process them, because these substituents will be ones that you use throughout the course, and you want to be able to quickly identify them as well as use them in an IUPAC name.